Now we look at MRSM paper 2. Question number 1. Diagram shows the connection between the nanoscale and the materials. Nanoscale and the materials around us. Okay. Now you can see the value of this. This one's 10 power negative 1. This one is 1. Then 10 power 2. Negative 2 what should be? Right. Wait. Okay. Or this. Okay. Next. Now, what is the mean by the nanotechnology? Yeah? Who wants to try? Cynthia? Okay, very good. It's a development of substance or gadget. Okay, using the property of nanoparticles. Okay, so this one is a standard definition. Okay, so you must write it correctly. Now B, list 2 uses of nanotechnology in our daily life. Okay, Jonathan, can you give one? Pardon? In agriculture. Okay, Ken. Agriculture. Yes, list only. List. Okay, what else? Food. Okay, Ken. Any 2? What else? A lot, right? Okay, cosmetic. Okay, what else? Medicine, right? Okay, what else? Okay, textile, etc. You can write a lot which are related. Any 2? Okay, next. Okay, so graphene has garnered wide attention materials in the nanotechnology. Explain how the characteristics of the graphene that allows it to be used in the sensor production. Okay, so in sensor, how the graphene can be used? Okay, class. Okay, high conductivity of what? Okay, of heat and electricity. Okay, what else? High sensitivity, can. Okay, what else? Okay, yes. First, we mentioned about that. Point number 1. It has high surface area. Okay? Surface area, luas permukaan yang tinggi ya. Okay, so point number 2, so that it has what? High sensitivity. So that's why we can use it as a sensor. Okay, so we've related to the properties of the sensor. So why we need to use it? Then, okay, it can produce a smaller size device. Because sensor, if smaller, is better. Okay, so it can produce smaller size device. Okay, so these 2 as a sample answer. Okay, so everybody record down. the answer. Okay, next. Question number 2. Diagram shows a graph of temperature against time for heating of solid substance Z to determine the melting point. Huh? Okay. Now, what is mean by melting point? First one, definition. Okay, Camilla. What is the definition? It is what? Okay, it is the constant temperature. Okay, then at which, okay, what change to what? Okay, a solid change to liquid, full stop, at a specific or certain pressure. Okay, so remember this is the definition. Now, what is the melting point of the substance Z? Anessa? Okay, 78. If you are asked to label it, you have to be able to label it. Use the dotted line. So 78. This one adjust a bit. So 78 unit degrees Celsius. Don't forget the unit. Okay, number 3. Okay, draw the arrangement of particles A to B. A to B is what physical state? Solid. So how do we draw the arrangement of particles? Okay, minimum 3 times 3 minimum. So 3 times 3 minimum. So it can be more. So 1. No overlapping. I think can. Okay. Lebih baik jangan. Okay. Kalau macam ini ada sedikit gaps sebenarnya tidak bagus sudah. Kalau boleh kamu padamkan, lepas tu lukis balik. Okay. So 3 times 3 minimum. Remember. Okay. The temperature B to C is constant. Why? Jerome. Okay, the heat release to the surrounding is balanced. Okay, balanced by what? Anyone notice something? Not anyone notice there is something not correct? Yeah. In here we not emphasis on this grammar. What is wrong? This is what? This is melting point, right? Melting process, right? Okay, so it shouldn't be heat release. Heat release should be freezing, right? Freezing Okay, so the correct one should be what? Okay, heat absorbed is used to overcome the force of attraction between the particles. So this is for melting. Okay, melting process. Okay, the other one just now. Okay, the one just now. Okay, is a freezing, for example. Okay, the heat release to the surrounding, okay, is balanced by the heat release during what? Bond formation, right? Okay. Okay, the following chemical equations show the reaction to produce a salt. Okay, satu garam. Now, class, what is this? What is the name for this chemical? C2H5COOH. Huh? Yes, very good. Okay, propanoic acid. Okay, how about this? NS2CO3. Okay, sodium carbonate. Okay, so during this reaction, you produce a salt, carbon dioxide, and water, right? So, what is the name for this salt? Sodium propanoate. How to spell? Sodium PRO-ATE. Okay, sodium propanoate. Yes. Okay, so the name for the salt is sodium propanoate. Okay, sodium propanoate. Okay, now give the qualitative and quantitative information. Okay, so class, if qualitative, what do we put normally? Class, if the question asks you qualitative information, what do we include normally? Yeah, Hanyi, what do we include in the qualitative information? Okay, more specific, the name for the what? Okay, the name of the reactants, and then the products. Okay, then. So for qualitative, okay, how do we write our answer? The reactants are what? Here, no? What? Propanoic acid and sodium carbonate. Okay? So here, these are the reactants, right? Bahan tinta bas. Okay, the products are okay, sodium propanoate. Okay, what else? Okay, carbon dioxide and water. Okay, so this is what you need to write in the qualitative information. Okay, that? You must remember reactants and products. Okay, how about the qualitative? We include the number of mole. Okay, number of mole. So here we just use this information. This one is 2 mole, this one nothing, 1 more, this one 2 more, this one 1 more, 1 more. Okay on that? So quantitative. Okay, so we include the number of mole. Okay, so 2 mole of propanoic acid, okay, react with how many more? 1 mole of sodium carbonate, okay, to produce 2 mole of sodium propanoid, right? One more of carbon dioxide and 1 more of water. Okay, so this is how we define the quantitative information. Any question? Okay, class? Anything you want to ask? I think better you write the name lah. Huh? Okay, class. Now calculate the total number of atoms in carbon dioxide gas. Okay, number of atoms in carbon dioxide gas when 26.5 grams of sodium carbonate is used. Okay, so class, first what we should write, we should calculate. Okay, number of mole 4 of sodium carbonate. So we have mass 26.5 over the molar mass. So what is the molar mass for this sodium carbonate? 106. Is it? So what is your answer? 0.25. Okay, 0.25. Okay. Number 2, we need to find the mole ratio. Okay. So mole ratio, we have to look into the equation. Mole ratio, this one is 1 mole. Carbon dioxide is also 1 mole. So we have to count also. We have to write also. So 1 mole of sodium carbonate. So produce 1 mole of carbon dioxide. So if 0.25 mole of sodium carbonate, so you produce same 0.25 mole of carbon dioxide. Okay. Now, okay. Now you have the number of mole already, right? 0.25 mole. Okay. Can you find the number of atoms, carbon dioxide atoms? Okay. So atoms here, be careful. So it's what? Mole times Avogadro constant Na. Okay, is this the only one we need to count? What should we do? Adakah ini saja? Mole times Na times 2. Why? Is it 2? 2 or 3? Huh? So here 1, here 2, right? So this one 1 plus 2. So 3, yeah? 3. So times 3. So mole is 0.25. Na is 6.02 10 power 23 times 3. Okay, so use your calculator. What is the answer? Yeah? Johnson? 515 times power 23. Okay, so this is the answer. Okay, class, now we continue to question number 4. Now this table shows the proton number of 3 elements, 3 atoms of X, Y, and Z. Okay, they are not the actual symbol. Now X, Y, and Z with the proton number 12, 8, and 1. Okay, now class, before we continue, we can write out the electron arrangement first. Okay, Dawi, for X atom, 12 protons, what is the electron arrangement? 2.8.2. Okay, good. Okay, next, Matthias, Y, 8 protons. 2, 6. Okay. Then Z only 1, so 1. The electron arrangement is 1. Okay, now X. Atom X can form a cations to achieve a stable octet electron arrangement. So what is meaning of cations? What is this means? What is this? Yeah? Okay, positive charge what? Positively charged ions. Okay? Very easy. You see, if cations, right? CAT or ION. Here got a clue for you. Positive ions. Okay, no? Positive ions. Cations, positively charged ions. Okay. Now, the atom X, it can achieve stable octet, right? So what is the formula? Okay, we have to ask how the atom X achieve octet electron arrangement. Donate 2 electrons. Okay, very good. Donate 2 electrons. So after donate 2 electrons, what is the charge? The electron arrangement becomes 2,8. Then how about the formula? X. What is the charge? Okay, 2 plus. Okay, 2 plus. Okay, good. Next, element X react with Y to form a compound. Okay, X and Y plus. It will form what? Compound. What compound will be formed? Ionic compound, right? Ionic compound. So, if ionic compounds okay, have you tried? Yes. So 2, 6 for Y to add 2. So meaning that now X at 2 okay, 2, 8 for X. So is 2 positive, right? Okay. Then how about Y? Okay, 1, 2. 2, 3, 4, 5, 6. Okay, so 2 negative. Get that? So this 2 is come from the X atoms here. Okay. The charge must be correct. Okay, next. The chemical equation shows a reaction between the element Z and Y. Okay, so first balance the chemical equation. So how to balance it? This one times 2. Okay, how about this? 1 or 2? Okay, 1 or 2? Should be 2, should be 2. Okay? Okay. Y needs to be 2 because here got Y2, right? If you put 1, Y only 1, right? So you need to times 2. But when you times 2 for Z becomes 4. Correct? So this one 2 only, so also need to times 2. Okay? So this one 1 mark. Okay, now calculate the mass of the products when 0.05 mole of element Z is used. So Z, okay? So here already have the mole, so no need to count the mole. So we can directly go to count the mole ratio. Okay, so mole ratio 2 mole of Z, right? Produce how many mole of Z2Y? 2 mole of. Okay, then if 0.05 mole Z, so it'll be the same, 0.05 mole. Okay. Yeah, element Z. Yeah. Yeah. Yes. Oh, Z2. Sorry. You are correct. Z2. Okay. So more of Z2. Sorry, not the more. Should be mass. Mass of Z2Y. Okay, so you have the mole 0.05 mole times the molar mass. So molar mass Z is 18. Z is 1, no? So 1 times 2, 1 plus 16. So what is the value? Okay, 0.9 gram. Okay, yeah. So this is the mass of the Z2Y form. Okay, ratio, mole ratio 1 mark, then the mass 1 mark. So unit must be correct, must be stated correctly. Okay, it shows 2 carbon compounds in the reaction bottle A and B. So A is C5H10, B is C5H11OH. Okay, class, what is this? C5H10 is what? How can name? Pen? 10 or tin? Tin, Pentene. Okay, how about this? Yes, pentanol. Okay, alcohol. Okay, now what is the meaning of hydrocarbons? Only. Okay, mention the only. No, here you just look at this name. Not only the diagrams there. Compound, containing carbon and hydrogen only. Okay, because here mentioned about the hydrocarbons. Okay, not affected by these diagrams. Now, okay, what is the functional group? State the functional group. So, alkene is the homologous series. Functional group is? That is general formula. Class, what is your answer? Carbon, double bond, or double bond between carbon atoms. Okay. Can we write the? Can we draw the structural formula? Can or not? Can, because state you can write formula. You can write the name. Okay. You also can use the double bond. Okay. Like this. Okay. Because state. Nyatakan, nyatakan. Okay, now compound in the reagent bottle B can be produced from the A through a reaction. What is this reaction? Okay, good. Hydration. Okay, hydration. Okay, next. Write the chemical equations. Hydration. So C. Okay, react with water. They will produce C5H11OH. Okay? Okay, next. This madam, it needs a field which do not cause the surface of her new pot becomes black. Okay, just now we mentioned already, this black is actually is a soot, is a carbon. So suggest which compound to be used as a fuel to prevent the pot become black, and then explain your answer. Okay, so what should we do? What should we do? We need to, okay, you need to find the percentage of carbon. Okay, so in A we need to calculate the percentage, right? So there are 12 carbons. Okay, pentane, pentene. So H is 10, right? Times 100%. So how many percent? 85.71%. Okay, how about B? Also 12 carbons plus 5 times 11 plus 11 plus 16 plus 1, right? Times 100%. So how many percent? Right? Okay, so how many percent? 68.18%. Okay, so which one will fulfill the needs of this one Rama? A or B? Huh? We want to see if A percentage is higher, meaning that more carbons, right? Okay, so more carbons, more black soot, right? So you should choose B. Okay, so you should choose C5H11 or H. Okay. Then why? Because the percentage of carbon by mass in compound no. Okay, of okay, is lower than the pentene. Okay. So remember, okay, this question also very popular in the SPM questions. So you should be able to justify, okay, more percentage of carbons, meaning that the sootiness will be higher. Okay, more soot. Okay or not? Okay, now we look into question number 6. Diagram shows the graph of mass of zinc. Okay, so during the reaction. Okay, mass of zinc, okay, against time. So we want to study the rate of reaction between the zinc and hydrochloric acid. Okay, so in this experiment, 4 grams of zinc added to 100 cubic centimeter, 1 mole per cubic decimeter. Okay, so class, you are given 4 grams zinc and then the hydrochloric acid. Okay, so both are given. How do we know which one is limited reagent, which one is the excess reagent? Huh? Which one is the excess, which one is limited? Zinc is what? Zinc is limited or hydrochloric acid is limited? How do we determine? If we say zinc, why? If we say hydrochloric acid, why? Yeah, okay. One obvious thing here is, you see here after the reaction is completed, the mass of the zinc still remains. In other words, the excess is the mass of the excess is the zinc. Meaning that hydrochloric acid is limited, will use up. Okay, dia akan dihabiskan dengan lebih cepat. Okay, here you have the graph. If no graph, how do we determine? Yes, we calculate the number of mole. We calculate the number of mole. This one use the MV over 1000. Okay, this one we use the mass over molar mass. Okay, so what is the mole? Then we compare. The smaller number of mole is the limited reagent. Okay, but here we know already is the hydrochloric acid is limited. Okay, because zinc is remains. Now, what is the meaning of rate of reaction in this experiment? So we have to refer to this experiment, not using the normal one. So how do we determine the rate of reaction based on this experiment? Okay, yeah, change of mass, okay, or decrease. Okay, it will decrease, right? Okay, change of mass of zinc. Okay, over the time, so per unit of time. Okay, here we also accept, except here we use the decrease. Okay, also can. Change is safer because sometimes it's increase, sometimes it's decrease. So you use the change will be safer. Okay. Now write the ionic equation for this reaction. Ionic. How do we write? So here actually we can refer to the collision theory. It will give you idea. Okay. So in this case, what are the collision particles? Yeah, zinc is zinc atoms. Zinc atoms. Then for the acid will be hydrogen ions, right? Okay. So meaning that here roughly we'll know zinc atoms react with hydrogen ions. Okay. So you produce what? Zinc ions and then hydrogen gas. Okay. Then how do we get this ionic equation? Okay, so we balance the equation first. This one times 2. Okay. So how to get this actually? So we can write out the overall chemical equation first. Okay, zinc react with hydrochloric acid, right? So it forms a zinc chloride and hydrogen gas. Okay, then here atoms, molecules, gas. Okay, or you remain this as the normal one, okay, initial one. So zinc remains, okay, but hydrochloric acid is the acid, right? So acid, what are the ions? So this one times 2, huh? So 2 hydrogen ions and 2 chloride ions. So this one. Zinc chloride is soluble salt, so zinc ions. And then this one chloride ions. Okay. Hydrogen gas is in the gas form, so it remains. Okay. So the same one we can cancel. So it's the chloride ions cancel same, right? So we cancel it. Okay. Then remaining one will be zinc with hydrogen ions, produce the zinc ions and hydrogen gas. So this is how we get the ionic equation. Okay. So the clue here, later you will see the collision theory we mentioned about zinc atoms, then hydrogen ions, right? Okay. Now, okay, C1. Why does the curve of the graph remain constant after T1 seconds? After T1, it remains constant, no more changes. Okay, why? What is the answer? What is this means? Okay, what is react completely? Dissolve, react. Here we react. What is completely react? Is it zinc or hydrochloric acid? Hydrochloric acid, the limited one. Because zinc not yet reacted completely, it still remains 0.75. Okay? So what you can write is or the hydrochloric acid has fully reacted. Yes, completely reacted also can. Or reacted completely also can. Yeah, completely also can, huh? Okay, now next. Determines the mass of the zinc that reacted in this experiment. So, what is your answer? How to get? Okay, 4 minus 0.75, so equals to 3.25 gram. Okay, yeah. Okay, now this experiment was repeated by using same quantity of all reactants to produce a curve Y. Okay, curve Y. Okay, initially is initially is like this one. Now curve Y. Okay, so class, curve Y, it has higher rate of reaction or lower rate of reaction? Higher. How do you know? Okay, here you see, time taken is shorter to completely react with the hydrochloric acid, right? Because after this time, there is no more changes, meaning that it reacts faster, no higher rate of reaction. Okay, now, okay, suggest one factor to produce the curve Y. Okay, so how to produce the curve Y? And then explain your answer by using the collision theory. 4 marks. What are the possible answer? Yeah. Okay, use what? Okay, use the catalyst. Yes. What catalyst we can use? What catalyst we use? What? What catalyst is what catalyst use? Sometimes you have to, if mention in here, if you write catalyst, it's correct already. But sometimes in the answer scheme, they ask you to write the example, so you have to know also. So acid with the zinc or magnesium, what catalyst we use? Okay, remember one, copper 2 sulfate solution, no? The blue color copper 2 sulfate solution. Okay, can. Okay, catalyst can. Okay, beside catalyst, huh? Temperature, yes, you can increase the temperature. Oh, make the temperature higher, so it also can react faster. Okay, beside that, concentration. Concentration, but concentration, let's check. If concentration, you have to adjust the concentration not allowed. Why? Because it say here, the condition should be the same, right? So if you increase the concentration, then your volume, your number of mole will change, right? If number of mole will change later on, your mass of the zinc remains will be different already. Okay? So volume, concentration. So you have to be very careful. Okay, it will change the number of mole actually. Okay? So beside temperature, another one is what? Powder, that is a size. That is the total surface area. Okay, so how to increase the rate of reaction? By using the factor of size. Use zinc powder or smaller size, larger total surface area. Okay, so you pick one to answer this question. Okay, but you need to use the collision theory. So which one you choose? Size, concentration. They in your practical test already memorized, right? Still remember? Masih ingat? Hey, okay. So you have to remember lah. Okay. So okay, size. Let's say you use the size. Okay. So we use a smaller size, right? Smaller size of zinc. Okay, or can use zinc powder. Okay, now zinc powder has what? Okay, larger total surface area. Okay, then after that, frequency of collisions between what particles? Okay, zinc atoms and hydrogen ions is higher. Okay, then finally frequency of effective collisions. Yang lain sama lah, between zinc atoms and hydrogen ions is higher. Okay, so point 1, point 2, point 3, then point 4. Okay, point 3 and point 4 just difference of one word. There is the effective collision. Okay, next question number 7. Thermochemical equation below represent two neutralization reaction. Okay, so already given to you. So first one, okay, KOH represent what? Potassium hydroxide. Strong or weak? Strong. Strong acid or alkali? Alkali. Okay, then this one is hydrochloric acid. Strong, weak? Strong. Okay, so salt and water. Okay, now number 2, set 2. Potassium hydroxide will be the same. Then what is this? Second one. Ethanoic acid, strong or weak? Weak acid. Okay, weak acid. So weak acid here, 50.0 kilojoule per mole. Heat is released, right? Okay. Then how about Y? Should be higher than 50, right? Do you know what is the theoretical heat of neutralization? Already memorized? Belum. Okay, so it's actually is 57.3, yeah? 57.3. Okay? For strong acid, strong alkali. Okay? Now, first question A, what is the type of reaction? Exothermic reaction, exothermic. Okay, exothermic reaction. Now, okay, diagram shows the apparatus. Okay, for set 1. Okay, so acid, alkali, 29. So highest temperature after they mix together is 35.5. So what is the temperature change, class? Minus, so you get 6.5. Okay, so you get the theta is 6.5 degrees Celsius. Minus only. Here, how to get the initial? Total up divide by 2. Okay. Next, calculate the heat of neutralization for the reaction. Okay. So volume and concentration for acid and alkali, they are the same, right? Okay, so first, what should we do? We can calculate the Q first, also can. Number of mole also can. Let's say, okay, we find the Q first. Q equals to mc theta, right? Okay, so what is the M? Trinity? How to get the M? Not the mole, not the mole. M is the mass. How to get the mass? Find the volume. Okay. So what is the volume of the solution mixture? 100 only? 200? Okay. Acid is 100. Alkali also 100. Total out. Okay. C? Okay, 4.2 theta, just now we mentioned already, 6.5. So you will get 5460 unit joule, joule. Okay, PB okay not? Okay, not? So here you must remember Trinity, how to get the M, the volume, total up the volume. Okay. Then second one, we can calculate the number of mole. Okay, for acid or alkali will be the same. Okay, if not the same, we have to calculate both. Then choose the smaller number of mole. So M V over 1000. Okay. So how is the value of M here? Concentration 0.1 V 1. 1. So 1.0 over 1000. So you get 0.1 mole. Okay. For acid and alkali are the same. Sama. Okay, then finally we can calculate the delta H. Q over the mole. Oh, yeah. Find the mole. Yeah. Okay. Mass, ini kah? Ini kah? If number of mole, we focus to one solution only, either acid or alkali. Okay, yang tambah itu dia hanya untuk Q equals to MC theta itu. Baru kita tambah. Sebab dua-dua sudah mix together. Boleh? Okay, please ask if you are not sure. Then Q is here. We can change to kilojoule first. Divide by 1000, right? For 6 kilojoule. So this one actually you remain in the joule also correct, not wrong. Okay, for 6 divide by mole is 0.1. So you get 54.6 kilojoule per mole unit material total. Okay, then here, okay, the delta H equals to negative 54.6 kilojoule per mole because it is exothermic. Negative show the reaction is exothermic reaction. No? Any question? Jonathan, okay. So remember, class, in the heat of reaction, first, second, then third. We follow the 3 steps. More you can calculate first, then Q later also can. It's up to you. Okay, then energy level diagrams. Okay, this one I would like you to try. Okay, draw the energy level diagrams. Okay, Jonathan, ready? 20, ready? Okay, sudah? Adrita mana? Absent lagi ke? Okay, next. So we draw the energy level diagrams. Okay, so Y. So must label energy. Okay. Then for exothermic reaction, go down, right? Okay. Okay. Then put in the delta H. Just now what we calculate. 6. Okay. Then we have to put in the reactants and products. So, okay. Then KCl, H2O. Okay. Some students, if you are smart, you will know what is the ionic equation for this reaction. Okay, OH, sorry, not here. OH minus H plus, then produce H2O. Okay, ionic equation will be like this. Okay, so this one, you also can put it here. Both are accepted. Okay. Okay, number 3, compare the value of the heat of neutralization for set 1 and set 2. Then explain your answer. So 3 marks. Okay, let's try this question. Okay, question number 8. Table shows data experiment about the hardness. Okay, hardness of the pure copper and its alloy. Okay, so pure copper. And another one, the alloy is brass use. Okay. Now, class, you can see the copper, the diameter of the dent, centimeter. Average is X. Y for the brass. Okay. Now everybody, can you calculate the average for X and Y? How to calculate? Total up, then divide by 3. Okay, so what is your value? 5, 6. Okay. 5, 7 or 5, 6? 5, 7, Okay, now how about Y? 2, 6 or 2, 7? 6, 7 or 6? 6, 7, so 7? 2, 7. Okay? Now, which one is harder? Huh? Which one is harder? Second one, the brass harder because the dent is smaller. Huh? It is not by the steel ball, right? Then the dent is smaller, means it is harder. Okay? Now, what is mean by alloy? Definition? Who can try this? A mixture? Two or more elements, okay, in which the major component is a metal. Okay, so this is a definition for alloy. Now, for brass, how is the arrangement? Okay, so for this zinc and you have copper, right? Zinc and copper, which one has a bigger size? Zinc, bigger size. So how do you know? Actually, here in the paper 2, you are given the periodic table. So you can check from there, the size. So zinc, bigger size. So in other words, the bigger size, zinc, then it is surrounded by smaller size. Like drawing a flower, right? Okay. Okay. Then remember, after you draw, right, you have to label. So these are copper. All these are copper atoms. Then this one bigger size is zinc atom. Okay. Okay, now calculate the value of x and y, 1 mark. So you total up. For x, show your calculation. 0.6 plus 0.5 plus 0.6 divided by 3. So 0.57 centimeter. Okay, y. Divide by 3. Okay, so you show your calculation. Okay, now glass window in some buildings is made of photochromic glass that turns dark when exposed to sunlight, but because the formation of the silver atoms that accumulate and block the light rays. Okay, state the major component in the photochromic glass and justify its use. Okay, so 3 marks. So what are the major components in the photochromic glass class? Okay, silver. Where silver what? Silver chloride. Okay, so 0.1. Okay, silver chloride. Okay, or you can use the formula AgCl because here state nyatakan. So you can use the name, you can use the formula. Okay, now so class, do you agree to use the photochromic glass in the building? Your answer can be yes or no, but you need to justify. Okay? So you agree or not its use? to this to make the glass turns darker when exposed to the sunlight. Okay, so let's say you agree, yeah? Okay, so let's say it's used, yes, agree, it's used. Okay, so why you agree with it? If it turns darker and then it blocks the light's ray, okay, yes, it can protect the humans from the UV rays, right? Okay, yes, protect from UV rays. Okay. Anyone you say not agree? If not agree, what is your reason? Yes, expensive. You are not agree. It is very expensive. Huh? So remember, every year in the SPM will be questions like this. So you have to justify. Actually, very simple. You just mention you agree or not. If you agree, what is your reason? If not agree, what is your reason? Okay? Mesti tulis lah. Okay? So the clue is, let's say at that moment you are not sure what to write. So the cost can be one of the reason for you to justify the cost. Maybe you say it is very cheap or it is very expensive. Can be one of the reason. Let's say you really don't know what to write. Okay, boleh, Jerome? Okay, now C. It shows a archway of Istana Negara, which the main material made is the concrete. Concrete. Now you are assigned to build a model of archway in your school. Suggest how a high quality and strong building structure can be produced. Okay? So class, how? We use what? This one is concrete, right? So how to make it more durable or stronger? We use the what? Steel, right? Okay, sorry. It will be reinforced concrete. So how to produce a reinforced concrete? We put the sun steel bar inside the concrete, right? Okay. So what you can write? Or wire is immersed into concrete. Okay. Is strengthening substance. Okay, strengthening substance. Bahan pengukuhan, bahan pengukuhan. So reinforced concrete has what? High compression or stretching strength.